Hi everyone! So today we're doing lesson 4.2 on arithmetic sequences. So an arithmetic sequence is a sequence in which the difference between any two terms is a constant. And so every single time you're either adding a constant or subtracting a constant in order to get the next term. So for my recursive formula for any arithmetic sequence, you'll start out with a sub 1 equals some numerical value. That would be the first term in my sequence. The next term is going to be equal to a sub n minus 1, the previous term, plus d. And d right here is called the common difference. So an example of an arithmetic sequence might be, let's start with 5. Let's say my common difference is 2. So that would mean I'm adding 2 to every previous term. So I'd have 7, 9, 11, 13, So that's an example of an arithmetic sequence. Or maybe let's start with 14. And let's subtract 3 every time. That would be 11, 8, 5, 2, So here in the first one, that's an example where I have an arithmetic sequence where my common difference is 2. The second example is an arithmetic sequence where my common difference is -3. So let's take a look at an example. Consider the arithmetic sequence below. A sub 1 equals 3, and a sub n is equal to a sub n minus 1 plus a 5. So I can see here, plus 5, this is my common difference. What are the first 3 terms in the sequence? So the first term, when n is equal to 1, let's make a chart. When n is 1, the term is 5. Nope, it's 3. Just kidding. 5 is my common difference. A sub 1 is 3. The second term in the sequence, I'm going to add 5 to that, and I'm going to get an 8. The third term in the sequence, if I add 5, is going to be 13. So first 3 terms of the sequence, if I were going to write that out, I would say 3, 8, 13. Now the next question says, what is the 100th term in the sequence? So when I'm thinking about that question, the 100th term in the sequence, the only way that I really know how to do that right now is to literally go out 100 terms. And that's going to take me a long time. So I'm wondering if perhaps I can come up with another method to find that 100th term. And that other method would be to find the explicit formula for an arithmetic sequence, where I could just plug in 100 as my input, and my output would be the actual 100th term. So let's take a look at the sequence in terms of a function. Let's think about it as a function. So what I have now is if I input 1, my output is 3. When I input 2, my output's 8. When I input 3, my output is 13. And I notice that because I'm always increasing by 5, I see this linear behavior. And I notice that if I were to calculate the slope, the rise over run, I'm rising 5 and I'm running 1 to get to the next term of my sequence. So the slope of this line is 5, and 5 is also the common difference. So what I'm thinking about is if this sequence behaves like a linear function, well, I know how to find the line of this linear function. I know that I could use slope-intercept form, y equals mx plus b. Y is equal to 5x plus b, because 5 I just said is my slope. So what I need to do is I need to figure out what would the y-intercept be to find that b value. Well, if I'm starting at this point at 3 and I go down 5, that's going to put me at -2. So if I go down 5, left 1 to generate this slope, I can see my y-intercept is -2. So this function is y equals 5x minus 2. So therefore, my a sub n is equal to 5n minus a 2. And this is my explicit formula for my sequence. Notice when I plug in a 1 for n, a sub n is 3. When I plug in a 2, I'd get 10 minus 2, which is 8, which is my second term in my sequence. And when I plug in a 3, I get 5 times 3, which is 15, minus 2, which is 13. So I can see that this arithmetic sequence behaves like a linear function, and all arithmetic sequences are going to behave like linear functions because they're increasing or decreasing by that common difference every single step. And that slope is always going to be the common difference. So what I want to do now is find the 100th term of the sequence by plugging in 100 for this n value. So a sub 100 will be 5 times 100 minus 2, which is 500 minus 2, 498 will be the 100th term in this sequence. Now what I want to do is I want to look at this explicit formula for an arithmetic sequence. So this says if you know a sub 1, which is the first term, and d, the common difference, then you can plug those in for a sub 1 and d, and you can simplify and get an explicit formula for your sequence. Let's check and see if what we came up with in the last example checks out. So here in my last example, my a sub 1 was 3, and my common difference was 5. So first, let's clean that up by distributing the 5. So while I have 5 times n is 5n, and 5 times -1 is -5. So then I have my 5n, and I can combine my like terms, 3 and -5, to get a -2. So that is what we saw. I do want to draw some parallels again with how this relates to a linear function. Notice that my common difference is here, and that is going to be equal to the slope of the line. This -2 was the y-intercept of my line, which very loosely correlates to the 0th term if it existed. Let me explain what I mean. I need a little more space. So my sequence in the last example was 3, 8, 13, ... So you know that the 5 is this common difference every single time. And we know here 3 is my first term, my a sub 1. So think about, if a 0th term existed right here, let's say 0th term right there, if it existed, what would it be? Well, since I'm adding 5 to every term in the sequence to go back a term, I would have to subtract 5. And 3 minus 5 is a -2. So notice that 0th term is always going to be that y-intercept, or the b value of the linear function that correlates to the arithmetic sequence. So a lot of my students gravitate towards one method or the other, where they really like this formula and they feel comfortable plugging into the formula and they want to use that, which is completely fine. Others really like thinking about arithmetic sequences as linear equations, and so then they gravitate more to writing this like it was a linear function, where I have my common difference times n, and then plus that 0th term. But either way is completely fine. All right, so let's take a look at an example. I want to give the recursive and explicit notation for the arithmetic sequence given, 10, 12, 14, 16, 18. So I notice that my common difference is going to be equal to 2. So my recursive notation is going to be a sub 1 equals 10. a sub n is equal to a sub n minus 1, the previous term, plus a 2, such that n is greater than 1. Let's take a look at the explicit notation. So for those of you who like to think of this as a linear function, you know that a sub n is going to be equal to 2 times n, because it is increasing by 2 every time. And then you have to think about, okay, well, what would the 0th term be? If there was a term behind this 10, what would it be? So I'm going to subtract by 2 and see that it would be an 8. So a sub n is equal to 2n plus an 8. And you can make sure that that works by plugging in a 1 and making sure you get a 10, which I do, plug in a 2 and make sure I get a 12, which I do, and so forth. Or you can use your formula. If you want to use your formula, you have a sub n is equal to a sub 1 plus your common difference times n minus 1. And let's clean that up by distributing the 2 and then simplifying. So you have 2n and then 10 minus the 2 is an 8. So either way you want to think of it is completely fine. What I want you to do is pause the video and do this next example on your own, and then come back and check your work in just a second. Okay, so now that you're back and you've had time to go through this problem, let's see how you did. So here in this sequence, you start with 46, and every single term decreases by 6. So my common difference is a negative 6. So for my recursive notation, I've got a sub 1 equals 46, and a sub n is equal to a sub n minus 1 minus a 6, and then I need to set my domain as well for n is greater than 1. So now I need, for my explicit notation, for those of us who are going to think of this as a linear function, you have a sub n equals negative 6 times n, and then what you're going to do is you're going to say, what would that 0th term be if I was going backwards? So since I'm subtracting 6 each term, I need to add 6 to go backwards. And if I add 6 to 46, I'd have a 52. So I'll have plus a 52 for my explicit formula. If we're going to use a formula, then you have a sub n equals my a sub 1, which is 46, minus a 6 times n minus 1. When I simplify this, make sure you distribute the negative along with the 6. So you've got negative 6n plus a 6. So then a sub n is equal to negative 6n, and then I see when I add that 46 and the 6, I get 52. So either way is completely fine to find your explicit formula. All right, so let's consider the sequence defined by a sub 1 equals 12, a sub n equals a sub n minus 1 plus a 3, where n is greater than 1. So the first question says, is this sequence defined explicitly or recursively? So you can see it's defined recursively because I'm using a previous term to generate new terms. The next question is, what does a sub n minus 1 mean? Well, I know that stands for the previous term, or the one preceding a sub n. The next question, what is the first term in the common difference? So I can see the first term is 12, and my common difference is 3, because we are adding 3 each term. Let's write the first 4 terms of the sequence. So the first term is 12, and then they're increasing by 3 every single time. So the next term would be 15, then I would have an 18, and my fourth term would be a 21. Now the next question says, what would the 312th term be? And I certainly don't want to keep adding 312 times. So what I'm going to do is I'm going to find the explicit formula. So what I'm going to do is I'm going to use that linear function logic. I have a sub n is equal to 3 times n, since that's my common difference. And I would think, well, what would the 0th term be if it existed, if I was going back? Well, since I'm adding 3 to every term, I would need to subtract 3 to see that 0th term would be a 9. So my explicit formula is 3n plus a 9. If you are using the formula and you want to check behind me, then all you got to do is do a sub 1 equals my first term 12 plus my common difference 3 times n minus 1. And when you simplify that, you'll see that a sub n does indeed equal 3 times n plus a 9. Now to find the 312th term, I'm going to do a sub 312 meaning I plug in 312 for n, and then I add my 9. So when I do that, 3 times 312 will be 936 plus a 9, and then 936 plus the 9 will be 945. So there we go. All right, so let's take a look at this next example. The information about the following sequence refers to an arithmetic sequence. Write both the recursive and explicit formula for the sequence. So here I have p sub 3 equals 106, p sub 4 equals 89, and p sub 5 is equal to 72. So they've given me 3 terms, but just not starting with the first one. So this is what I've got. So it's kind of nice that they've given me some consecutive terms, because then I can see that in order for it to get from 106 to 89, I am subtracting, let's see how much, 17. And then to get from 89 to 72, again, I'm subtracting a 17. So that's my common difference. And to write recursive notation, I just need to figure out what that a sub 1 is. I can set my rule pretty easily now that I know that negative 17 is my common difference. So to find the first term, I'm going to go backwards and I'm going to add 17. So if I take the 106 and I add 17, I would be at 116, and then I need to add 7 to that, so 123. And then if I add 17 to that, I'm going to be at 133 plus 7, so 140. Now that I've got that figured out, I can write the explicit formula. So I've got a sub n will be equal to negative 17 times n, and then I need to think about what would be that previous term, the 0th term, if it existed. So I'm going to add 17 again to 140, so add 10, 150, plus 7 more, 157. Here's the explicit formula for this sequence. So if you're using the formula, you would have that 140 minus 17 times n minus 1. When you clean that up, you'll see we have the same thing. All right, I believe I have 2 more examples. In the first one, it says find the information about the following sequence refers to an arithmetic sequence. Write both the recursive and explicit formula for the sequence. So here, they don't give me the first term, they give me the 19th term, which is 48, and then they tell me the common difference is 5. So in the last example, going back and finding the first term wasn't too hard because I could count back 2 terms, but starting from the 19th term and counting back 18 more terms to get to a sub 1 doesn't sound appealing. So I think what I'm going to do is I'm going to use the formula for this. So my formula says a sub n equals a sub 1 plus my common difference times n minus 1. So let's plug in my common difference that they've given me, which is 5. I'm plugging this in. And now what I'm going to do is I'm going to plug in this term value. So a sub 19 is 48. And that equals a sub 1 plus 5 times my n value when I'm at 48 is 19 minus 1. So you can see where I'm plugging in my term value and the number of term it is, which is 19. And then I can clean this up and I can solve for a sub 1. So 48 equals a sub 1 plus 5 times 18. So 48 equals a sub 1 plus 5 times 18. I'm probably going to split that up and distribute. So I'll have 10 plus 8 is 18. 5 times 10 is 50. 50 plus 8 is 40. So that's 90. And then I'm going to subtract 90. So I have a sub 1 is equal to 40, negative 42 for a sub 1. And now I have all the information I need to write both the recursive and the explicit notation. For recursive, I've got a sub 1 equals negative 42. And a sub n is equal to a sub n minus 1 plus a 5, such that n is greater than 1. Now for my explicit notation, I've got a sub n is equal to 5 times n, and then I need to think about what the 0th term would be. So if you're increasing by 5 every time, what you need to do is subtract 5 from the first term. So if I were to subtract 5 from negative 42, I'd have negative 47 to see that would be the 0th term. Or what you can do is you can plug in, like always, your first term, which is negative 42, and common difference to your formula, and simplify it. And you'll see this right here. All right, so I've got one more example. In this example, it says the information about the sequence refers to an arithmetic sequence. Write the recursive and the explicit formula for the sequence. Here I'm given a sub 8, the 8th term is 21, and a sub 27, the 27th term is 97. So here I'm not given the first term, I'm not given the common difference, I'm given two different terms in the sequence. So what I'm going to do is, again, I'm going to think about this as a function. So it says the 8th term is 21, and the 27th term is 97. So if I were to think about these as points in my sequence, I know it's arithmetic, so it behaves like a linear equation. And if I find the slope of this linear equation, well then I'm going to be able to use that as my common difference. So you can have some choices. You can do rise over run. So to rise from 97 to 21, that's 76. And to run from 8 to 27, that's going to be 19. So my slope is 76 over 19. That works out really nice. It's just a 4. Or you could have used slope formula if you wanted to. If you think about these as points, 8, 21, and 27, 97. You can do m equals y2 minus y1 over x2 minus x1. Change in y over change in x. Here you see your rise of 76 and your run of 19, which simplifies to be a 4. So either way you choose to think about it is completely fine. So now I know my common difference is 4. And now what you can do is you can choose a point to work with, and you can use that just like we did in the last example. I'm going to use the first point since 8 and 21 are smaller numbers to work with. So I'll have a sub n equals a sub 1 plus 4 times n minus 1. And now when I plug in this term, the 8th term, I get 21 equals a sub 1 plus 4 times 8 minus a 1. 8 minus 1 is a 7. And then I'm going to multiply the 4 times the 7 to get 28. When I subtract the 28, you got a sub 1 is equal to a negative 7. So now I have everything I need for that recursive notation. Got a sub 1 equals negative 7, and a sub n is equal to a sub n minus 1 plus a 4, such that n is greater than 1. There's my recursive notation. Now for my explicit notation, I'll have a sub n equals 4 times n, and I need to think about what would the 0th term be. Well, if the first term is negative 7, and I was going back a term, I need to subtract 4. So I'd have negative 11. Or if you wanted, of course, plug on into your formula, you'd have negative 7 plus 4 times n minus 1, and you will end up right there. All right, so that concludes our lesson on arithmetic sequences and finding recursive and explicit notations for arithmetic sequences. Again, in review, an arithmetic sequence is a sequence where you have a common difference between every term, and that it can be positive or negative, so you're adding or subtracting the same numerical value each term. And arithmetic sequences behave very similar to linear functions. So if you treat it like a linear function, that slope is always going to correlate with that common difference. And your 0th term is always going to be the y-intercept of your explicit formula. So I think that's it for this lesson, and you're all set to do the problem set now.